Hello, friends. How are you? I hope you are doing good. Today, we will learn about the system of forces and equilibrium, and we will also calculate the support reactions. System of forces. Suppose this is a body, and the forces are acting on the body. One force here on downward direction, and one force here on upward direction. So, what is the net force acting on the body? We will see. So, is this body in the equilibrium? It is in static equilibrium, it is in translational equilibrium, or rotational equilibrium. We will see about it. And if these two forces are acting like this, then what is the net forces? And is this in static equilibrium? We will see about it. So let's get started.
Engineering Fundamentals from the Appendix B, page number B-7 to B-8 by the manual detailing for steel construction by Yugandhara Tayale. Content of the video is Introduction, System of Forces, Sign Conventions, Equilibrium Conditions, Reactions, Free Body Diagram, Determinacy and indeterminacy with some examples. Today we will see about equilibrium conditions. So about what equilibrium? For that you need to understand what are the types of supports, what are the forces, what are the loads, moment and couple. I have made videos on these topics. Links for those videos is provided in the description box below. Please watch those videos before for better understanding. System of forces. Any collection of forces and moments in 3D space is statically equivalent to single resultant force vector plus a single resultant moment vector. That is, force is summation of all the forces acting on that body, and moment vector is summation of all the moments acting on that body. Either force vector or the moment vector or both force and moment vector can be zero. So forces. Here on rigid body A, two forces are acting. Horizontal force HA acting towards the right and horizontal force HB acting towards left. For sign convention, we take horizontal force acting towards right as positive. So here only horizontal forces are acting on a body. So F, that is total forces acting on the body, is F is equal to summation of Fx, which is HA will be positive and HB will be negative. So its sum will be HA minus HB, the net force acting on the body. In the similar way, here vertical forces are acting on the rigid body A. Vertical force VA acting upwards and vertical force VB acting downwards. So for sign convention, we consider vertical forces acting upward as positive. So net forces acting on this rigid body will be calculated as F is equal to summation of Fy, which will be VA minus VB. In this case, on the rigid body A, two moments are acting on the body. Moment MA, which is in clockwise direction, and moment MB, which is in anticlockwise direction. For the simplicity in the calculation, we consider clockwise movement as negative. So M is the summation of all the moments acting on the body, which will be MB, which is in anticlockwise direction, so considered as positive, and MA, which is in clockwise direction, so considered as negative. So net moment acting on the body will be MB minus MA. Here, on this practical example, we will see how to calculate resultant of forces. Consider this as a table, and these two men are pushing it. So this one man is applying a force of 40 Newton, and here the second man is applying a force of 30 Newton, and both forces are in the same direction. So F net, that is total horizontal force acting on this table, will be 40 Newton plus 30 Newton. And yes, the direction is also important. So F net will be 70 Newton in the same direction as that of both of the forces. In the second case, here a 40 Newton force is applied towards the right and 30 Newton force is applied towards left. So F net, that is total horizontal force acting on the body, will be 40 Newton minus 30 Newton, which will be equal to 10 Newton, and its direction will be in the direction of larger force. Now here in the third case, a 40 Newton force is applied in the horizontal direction and 30 Newton force is applied in the vertical direction. So F net, how we can calculate it? So we will consider these two in right angle, and we will apply a hypotenuse theorem. So 40 Newton and 30 Newton resultant will be 50 Newton. For calculating resultant of moments acting on a body, consider this example. Here, a book of mass 4 kg is held in hand. So, here biceps muscle and triceps muscle force is applied. Then center of gravity of hand and weight of this book acting at the CG. So in the further of the video, we will understand what is this diagram. It is called free body diagram, FBD. But now we will understand how to calculate resultant moment in the body. So consider these are the forces acting on this body. Force Fe, that is force of the triceps muscles acting downwards, force of the biceps muscles acting upwards, Fb, weight of the hand acting at Cg, it is Wa, and weight of this book, Wb. So M, that is moments acting on the body, are summation of all the moments. And how they are calculated? As we saw in the previous video, moment is equal to lever arm into force. That is perpendicular distance from the pivot point and line of action of force, that is lever arm, and the force acting on the body. So here we will take moments at E. So at E, Fe into 0, because This force is passing through this point, so its lever arm will be 0. Now FB into R1, and its sign will be positive. Why positive? Because it is creating an anticlockwise movement. So FB into lever arm R1, it will be of positive sign. Now next force is WA. So the moment created by WA will be WA into R2, but it is in the clockwise direction, so it will be negative. So minus WA into R2. Next move force is WB. So WB, and the distance from the point E to force WB is R3. So WB into R3 is the moment, and its sign will be negative as it is clockwise movement. So net moment acting on this body is ME is equal to FB into R1 minus WA into R2 minus WB into R3. These are some of the concepts where moment is used, like this equilibrium concept. And here, time is important or money is important. And in this case, about the pivot point in the seesaw game, here two girls are sitting, and on this side, one boy is sitting. So, how they are balanced? Can you find about the movement about this pivot point? Can you?
Introduction video, I told you about the forces acting on this body. If one force is acting at this end from downward and other force is acting upward, then of course the net forces on this body are zero, as these two forces of equal magnitude cancel each other. So this body is in translational equilibrium. But if these two forces are of same magnitude, equal and opposite, and have different line of action, then of course this is in static equilibrium. Of translational equilibrium, that is summation of f is 0, but net moment is not 0, as this body will rotate like this. So this condition is called as partial equilibrium. The body can be both in rotational equilibrium and translational equilibrium if the forces acting are like this. They cancel each other. So this is the example of equilibrium.
Equilibrium requirements. To be stationary, all forces and moments on the object must be in equilibrium. Now, for an object to be in equilibrium, the resultant of force and resultant of moment vector both must be equal to 0. Equilibrium requirements for 3D system. So these equations are there. For determining an object to be in equilibrium, these 6 simultaneous equations must be solved. For determining an object to be in equilibrium, these 3 simultaneous equations must be solved. Example for beam, column, etc. Equilibrium requirements for concurrent forces. Concurrent force system is a category of force system where all the forces act at the same point. Then only force equilibrium is necessary to ensure complete equilibrium. Moments will be zero as they will pass through single point. So moment arm will be zero. So this is the very popular example. Here one ball is kept on this triangular surface. So these two surfaces and weight of the ball. So these three forces are acting through this single point. So we will consider only these three equations. Moment will be zero. Thank you so much to you all for being with me throughout this video. I'm grateful for your support. Happy learning! For the content in the video, all the credits are given to the AISC committee who prepared the manual detailing for steel construction, and also to the Michelle R. Lindeburg for the FE Civil Review Manual for Reactions Summary Table. If you find this video useful, then please share. It will help others, and subscribe to get notified about the new videos.